Okay, today we're going to do some word problems. So we're almost to the end of 8 and 4, and I think most of you've learned all the math so far. So they're going to spend 3 lessons doing some word problems and interesting applications of all the powerful stuff that you've learned. So I think this is great. And so, gosh, I really hope that you enjoy these word problems. I'm going to do today, I'm just going to work 5 different types of word problems that you might see. And so write them out. I'll kind of give you a general idea how to think about them maybe, and then solve them. And we're going to solve them again using linear equations, the simultaneous systems of equations, this powerful concept that you've learned over the last few lessons. So let's get on with it, and hopefully this is helpful. And if not, let me know. I can certainly willing to listen and change things up. And next time you see me, I'll have a haircut. Hair's getting a little long here. Lesson 30, we'll have short hair. So you can log into lesson 30 and check it out, see if I actually made it out on this rainy day. Okay, let's share this screen. Let's hit it. We're doing 5 different word problems types. So the first type of word problem that you're going to see is this sum and difference problem. Well, you're going to see hundreds of different types of word problems, but this one is a sum and difference problem. You'll see it a lot. You'll see this sum of 2 numbers is something and their difference is something else. And we learned how to write these, I think, all the way back in lesson 1, if you recall, how to take word problems, verbal models. You know, you took verbal models, and you turned them into equations, algebra. And there is a correspondence between English and algebraic equations. So the way we're going to solve all of these problems, we're going to have 2 variables. You can solve some of these problems with 1 variable approach, but we're going to do them all with 2 variables because there's always 2 unknowns. 2 unknowns. The unknowns are like, X and Y. Again, and what is algebra? Algebra, and one way to look at it is solving equations with unknown variables. That's one way to look at it. I don't know if that's the best definition. It's just kind of a working definition. It's certainly not a formal definition. So in this case, we have 2 things we don't know. We have 2 unknowns. What are the 2 things we don't know? Well, there's 2 numbers. We don't know what these 2 numbers are. And then you can look always at the question. The question will tell you what you are looking for. Almost always the 2 variables. Okay, so we don't know what these 2 numbers are. We know what you add them together to get, and we know what you subtract them to get. So if I don't know what are the numbers, and I have no other reason to call them, A or B or X or Y, I usually just say X and Y. I'll call them X and Y. So X is going to be my first number, and Y is going to be my second number. And why do I always write this out? I always write out your unknowns. This is going to become more important in some of the later word problems because first of all, it just tells you, it gives you a reference when you're going back and you're converting these verbal models, these word problems into English. Like watch this, watch what I do here. The sum of 2 numbers is 120. Well, what are my numbers? Oh, well, my numbers are X and Y. Cool. So my sum of my 2 numbers, X plus Y, which equals 120. Okay? Their difference there, meaning the two numbers difference is 42. So x minus y equals 42. This is so cool. I now have two equations, two unknowns. It's a system of equations. And I know how to solve those. I can solve it via substitution, but this one looks really neat. What does this look like? This looks like I could use elimination. Really easy. This one's set up for elimination. You could do it using substitution, but elimination is going to just let me solve it real simple and easy. I'm just going to add these down, and I get 2x. These are set up for elimination, equals 162. So if I divide by 2, I get x equals 81. Wow, awesome. Now I could say, now I got my first unknown, and so that's my x. This is 81. Well, yeah, we'll just leave that off for a second. We'll put it right here, 81. So my second one is y, so I know that if I plug it into either equation, I can find out what my y is. So 81, which is my x, plus y equals 120. And so my y, if I solve that, is 39. Cool. 39 and 81. Now, we can check that. So let's check. We know that x plus y is 120 because 81 and 39, we just used that equation to find our y. But let's see if their difference is 42. Is 81 minus 39 using the second equation. Does that equal 42? Well, let's see. 81, 39, 7, 1, 2, 42. Yes! A giant happy cat. We are so good. We checked our answer. And isn't it cool how you can use algebra to get these exact numbers? We could have just guessed and checked over and over and over again, but we used algebra to go right to our answer. Happy cat. Okay, so hopefully this makes sense to you. This is a good model. You're going to be seeing these kinds of problems on tests and on homework. So this is, I've seen this, I'm 50 years old, and I've been seeing this problem since I've been, 12, 13, 14, whenever I started taking algebra. I've been seeing this one for 38 years, and they still seem to like this model. So make sure you understand that one. Here's another one that we see. The sum of the ages of two sisters is 33. One sister is 3 more than twice the age of the other. What are their ages? So let's figure this out. What are our unknowns? Well, we have the younger sister and the older sister. Because ones must be younger. So we have our younger one, and let's just call our younger, in this case, we'll choose our younger one to be, y, because y for younger. And the other one, we'll just let the older one be called x. I wouldn't use O for older because it, O looks like a 0. I mean, O and 0 look the same. So I would always shy away from using O as a variable. So I'll use x for the older sister's age, younger's age. So the sum of the ages of the two sisters is 33. The sum is 33. That's not too hard. We saw that on the last one. The sum of their ages is 33. One sister is 3 more than twice the age of the other. So this has got to be the older sister. This has got to be the older one. One sister is 3 more than twice the age of the other. So this is where we start to get kind of a little bit more confused, maybe more confused with our word problem writing. But we say one sister is. So the older sister is x. So this is x. is. So we'll write this over here. X is 3 more than twice the age of the other. This is the younger. So 3 more than twice the age of the younger. Again, if you have trouble with this conversion and need a little further detail, you can go back all the way to back to 8M4 lesson 1, and I went over a lot of this word problem stuff. So you can refer to that video. So now we have 2 equations. Wow, 2 equations, 2 unknowns. So let's use substitution. And this is the way that this is, for some of you, you may be able to directly learn how to substitute this guy straight in here. But that's not the way they taught substitution in exactly how we've been learning it in Eureka Math. So I'm going to do it the way they did it in Eureka Math, and we're going to get our x. We're going to isolate our x's. So over here we have x equals 3 plus 2y. I'll just write that over here. X equals 3 plus 2y. In this top one, we have to subtract a y from both sides to isolate our x. So we get x equals 33 minus y. Right? You can see how we went from here to here. Now we can do substitution. So let's substitute this piece and this piece, because if the x's are equal, then these two have to be equal. So we'll rewrite our equation, and now we're down to 1 variable. Awesome. So let's add a y to both sides to put our y's on the left, and let's get our constants on the right, and we get 3y equals 30. Whoa, we're getting there. Y equals 10. So our younger sister's age equals 10. Let me just switch up colors just because I can. And let's figure out the older sister's age. Well, we can go back and we can use either equation. Let's use this. Let's use the second equation. So we'll say x equals 3 plus 2 times 10. So that equals 3 plus 20 equals 23. So x is 23. So now we're going to check and make sure that we got it right. So let's check with this guy, the first equation, and say, well, does 23 plus 10 equal 33? And the answer is yes, and we'll give ourselves a happy cat, and we are done with this problem. Now, you could say, well, Mr. Lipscomb, in this case, I actually haven't solved the problem because I don't have labels yet. And you could say, well, let's put this 10 right next to this, and we'll put the 23 right next to this. And then we can box those guys. And then we really do have a full answer, because the younger age is 10. The older age is 23. I could have written that neater. So let's make that be a big, bold 23. And we have our older sister's age and younger sister's age. Okay, let's move along. Problem number 3. 2 angles are complementary. No, my goodness, they're gonna hit us with a little geometry. But we can go back and remember our complementary rules here in a second, and we'll go through that trick one more time. 2 angles are complementary. One angle's measure is 3 times the other. Uh-oh, Mr. Lipscomb didn't ask a question, but what do you think the question is? And let's think about it. What is the question? Well, the question is, what are the measures of the 2 angles? Of course. And I have this on the last 2 problems. This is problem number 3. Problem 4 and 5, I kind of leave off the question, and I want you to see if you can guess the question, because that's going to kind of engage your brain and prepare it for answering the problem. So what are the angles of the measure of the 2 angles? Well, we don't know that. We don't know the 2 angles measures. So we're going to call them x and y, for lack of a better name. X equals the first angle, And we'll let that be the smaller. And then y equals the second angles measure. And we'll let this be the bigger. The bigger. Okay, now complementary. I want to remind you, let's go back and remember the difference between complementary and supplementary. Hopefully you remember that one is 90 and one is 180. But let's remember the trick. And this was taught to me by students. I didn't come up with this. Maybe in your class your teachers taught you this, but complementary, the way you can figure complementary is you just put a line here, and that's 90. In supplementary, you can put a 1 here and make this into an 8 and make that into a 0. And so a supplementary is 180 and complementary is 90 with that fill it in trick, right? 90, boom, complementary. 180, supplementary. Thank you to my students that taught me that about 4 or 5 years ago. Really cool trick. Okay, two angles are complementary, so they sum to 90 degrees. So I know now that x plus y equals 90. And I know that one angle's measure is 3 times the other. One angle's measure is 3 times the other. So this must be the small, and this must be the big. So we're going to say 3 times the small, 3x equals y. Cool. This is looking like a candidate for substitution. So I'm going to do this one with substitution. So we're going to say we have y isolated here. So let's isolate this one for y by subtracting an x from both sides. If I subtract an x from both sides, I get y equals 90 minus x. And there's my y. So if y is 3x and y is 90 minus x, then I can take these two guys and I can use substitution to say, well, 3x equals 90 minus x. I can add an x to both sides to solve and get 4x equals 90. Uh-oh, looks like a fraction's coming. So I get x equals 22.5. So that's my smaller. Now I can use x plus y is 90. We'll do that. 22.5 plus y equals 90. And if you do the math on that, you get y equals 67.5. And you can check it by saying, well, does 3 times 22.5 equal 67.5? And if you work that out, it comes to true. You get 30. I'm not going to do this math. I mean, you can do it. Well, let's just do it just for fun. So 22.5 is 22. That's 45 over 2. 3 times 45 over 2, right? 22 times 2 is 44 plus 1. And over here, I get 67 times 2. 67 times 2 is 4. Carry 1, 134. Yeah, 134 plus 1, 135 over 2. So 3 times 45 is 135 over 2 equals 135 over 2. Check, happy cat. And so I'm going to write my answer here. The smaller is 22.5. My larger is 67.5. And there's my answer. Box it up. Nice and tight. Good work. Happy cat. Moving along. Now these last two problems are both similar, but these are a little bit more involved. This is a bot. A little bit more involved, so let's go. So hang with me on this. So I went to the store and bought apples and bananas. I spent $2.30 and bought 10 pieces of fruit. If apples cost 25 cents and banana costs 20 cents, what is the question? How Well, what is it that I don't know? The question is going to be how many of each type of fruit did I buy? Mr. Lipscomb, did I buy? So we can use A and B because those don't look like numbers. It's not like O's, which look like zeros. So we're going to say A equals apples, number of apples I bought, and B equals the number of bananas I bought. Now on this one, I'm going to do another little hidden thing, or not a hidden thing. I'm going to show it to you, but I want to know that these kinds of problems mix numbers of apples, numbers of things, and the cost of things. So if I buy, let me ask you, if I buy a certain number of apples and apples cost 25 cents, what is the cost of the apples I bought? So let me just show you something. I'm gonna take a digression, but I think this is going to be valuable. So there's going to be a correlation between the number of apples and the cost of apples, and this is going to help you figure out what goes here. And we're also going to need to find the cost of bananas. Some of you might just have the cost of bananas. Some of you might just have the right intuition and know what goes in this blank, but it's not. I've found in the past that most 8th and 9th graders don't know this just intuitively. So let's just go through this example. If I buy 0 apples, the cost is 0. If I buy 1 apple, it's 25 cents and it's 25. If I buy 2 apples, it's 50. If I buy 3 apples, it's 75. So how do I get from here to here? What is the multiplier? Well, the multiplier is 25. It's times 25. Times 25. Times 25. And if I buy 10, it's 250 cents. Times 25. So if over here I have A, because I bought A apples, and I have to multiply by 25 to get to here, what goes here? Think about it. Well, if it's multiplying whatever's here by 25, and this is an A here, 25 times A is 25A. That's what goes here. So we're going to put 25A is the cost of my apples. And you can think about that. It'll start to make sense. Maybe it doesn't make sense right off the bat, but hopefully this chart gives you the right intuition. Now, similarly, the number of bananas and the cost of bananas, is 0, 20, 0, because these are 20 cents a piece, right? So 1, sorry, what am I talking about? 0 costs 0. 1 costs 20, 2 costs 40, so it's times 20. Times 20. So if I have B bananas, the cost is 20B. Now we're ready to solve the problem, and I'm just going to switch to blue here so that this is our setup. This is our setup. Now we're going to start to write the equations. So I bought 10 pieces of fruit. So the number of apples I bought and the number of bananas I bought needs to equal 10. So we write A plus B equals 10. The number of apples plus the number of bananas is the number of fruit. That's the number of fruit. Now the cost that I spent is got to be 230 cents. So here, this has to do with cost. Right? So the cost of the apples, 25A, plus the cost of the bananas equals 230. Okay, so now we have two equations and two unknowns. And here is a good, another good candidate for substitution, if you want. And so what we're going to do is we're going to solve for, let's do elimination. So we want to eliminate B, or do we want to eliminate A? Well, I'm going to eliminate B because it's going to be a smaller multiplier. I'm going to multiply this top one by 20. And I'm going to get 20A plus 20A plus 20B equals 200. And down here I have 25A plus 20B equals 230. Well, they're not going to be eliminated because these are both positives. I need to make one of them negative. So I should have multiplied by a negative 20. So if I would have multiplied by negative 20, I would have gotten negative 20A minus 20B equals minus 200. Okay. Now when I add down, these will eliminate. So we get 5A equals 30. So if we divide by 5, we get A equals 6. So we got 6 apples. Now I can do this next part in my head. If I had 6 apples, 10 pieces of fruit, that must have been 4 bananas. And that's my answer. Now let's just check and make sure our cost is right. And our cost needs to be 230. So if I bought 6 apples, I bought 6 times 25. I spent $1.50 on apples. And I spent 4 times 20. That's equal to 80. That's the cost of my bananas. So I spent $2.30. So that is worthy of a happy cat. Happy cat, happy cat spinning. Whoa, look at him. He's upside down. Upside down happy cat. Okay. Hang with me on these. These can be kind of tricky, but they all are going to work the same way. You're going to have this number of apples, number of bananas, cost of apples, cost of bananas. Now notice there's another type of problem that looks exactly the same. And that's going to be this nickels and quarters or dimes and half dollars or, nickels and pennies questions. They all work the same. So, and here's the question. If I have 22 coins that total 310, if I only have nickels and quarters, then how many, and how do we fill in the question? What is the question we're going to ask? How many of each coin do I have? Well, let's use N and Q because those don't look like numbers. So I'll say N equals the number of nickels and Q equals the number of quarters. Now think about what we did on the last one. We have this idea where we have a number. So this is my count or number of coins. Now we have to have another thing that says the cost or the value of coins. So let's look at our quarters. So if we have the number of, so let's just a sec. Let's do this. So let's do the value of nickels. So if I have, and so let's do our chart again. Number of nickels, and I want to convert that into the value of nickels. Well, if I have 0 nickels, I have 0 value of nickels. If I have 1 nickel, I have 5 cents. If I have 2 nickels, I have what? I have 10 cents. If I have 5 nickels, I have 25 cents. We can figure this out. So this is times 5 times 5 times 5. And so if I have n nickels, how do I get from here to there? Well, it's times 5. So I have 5n is the value of nickels. And so what is my value of quarters? If I have Q quarters, I don't need to make a chart. Let's not make a chart and let's just figure out what that is. If quarters are 25 cents, then it's 25Q. All right? And you can make a chart like this with quarters and use your Q here at the bottom to confirm in your own mind that the value of quarters is 25Q. Now I can move ahead and solve this problem. So my count is, these are my counts, N and Q. So if I have 22 coins, we have N plus Q equals 22. And now we have the value is 310. So my value, this is the value of nickels plus my value of quarters has to equal 310. So 5N plus 25Q equals 310. Now, what are we going to do? Let's do some, should we do elimination? Well, if we wanted to do substitution, we could do it like this. Well, let's do elimination. I just think these line up nicer to elimination. So we're going to multiply this one by 5. And just to look ahead, this is going to be a 5N and a 5Q. So these are going to be positive numbers. And so we're not going to get our elimination happening. So let's make this a negative. We're going to multiply by -5. So we get negative 5N minus 5Q equals negative 110. 5 times 22, 110. Now we have 5N plus 25Q equals 310. This is going to work out nice. These eliminate, add down, 20Q equals 300. Nope, 200. So Q equals 10. Dividing both by 20, right? Divide both by 20 and you get Q equals 10. So if I have 22 total coins, then that must leave nickels must be 12. You could have used this guy and you could have said N plus 10 equals 22 and said, well, N equals 12. That would have worked too. Now let's validate that we're not crazy by using this equation here. So 5 times, to check our answer and make sure we didn't do some bad math, 5 times 12 plus 25 times 10 equals 310. Does 60 plus 250 equal 310? Sure does. Happy cat, happy cat, happy cat. Spinning, spinning. Okay, so hopefully this was a useful lesson. These are what I call canonical, I don't know how to spell that, examples of word problems that you're going to see in everyday life. Well, certainly in everyday math, you're going to see lots of these. And you use the power of simultaneous equations, systems of equations, all the way back to lesson 1. So lesson 1 all the way up through lesson 28, we're putting it all together in these word problems. Make sure you know how to do these. Hopefully these word problems are getting easier and more exciting for you. And we're going to come back and we're going to do 2 specific types of word problems in lesson 30 and lesson 31 that are going to be extremely powerful for you in terms of finding Pythagorean triples. I think that's lesson 31. In lesson 30, you're going to prove the conversion between Fahrenheit and Celsius that you may have learned this formula in science class, but we're going to use mathematics to prove the formula. It is a cool lesson. Stay tuned, watch. Should have my hair cut by that time. Talk to you later. Bye.